Alright, so in our next section of chapter 12, we're going to be talking about the Pythagorean Theorem. So the longest side, which is opposite of the right angle, is the hypotenuse. So this in blue here, that's what we call the hypotenuse. Again, it is the longest side. It is always across from our right angle. I always, when I'm trying to find the hypotenuse, I go to the right angle and just draw an arrow across. It just helps me figure out which side the hypotenuse is. The other sides of the right triangle are what we call legs, because they hold up the hypotenuse, like legs hold us up. And so then why is this important? Well, it's important because there are things that we have to know in the for the Pythagorean Theorem. Just a reminder, we know a triangle is a right triangle as long as it has an angle that has 90 degrees in it. We know that this is a 90-degree angle because it has that box. So if a triangle is a right triangle, so that's what this triangle is, then the sum of the squares of the lengths of the legs, so our legs in this case are going to be A and B, is equal to the square of the length of the hypotenuse. So what that means is the sum of the squares. So we have A squared and B squared, and sum means plus, is equal to the length of the hypotenuse, which is C. Now, the hypotenuse is always C. So C always equals the hypotenuse. The other two legs, they don't matter. I mean, think about it. It's A squared plus B squared. I could make it B squared plus A squared. It's going to be the same thing on that side. But again, the hypotenuse always has to be C. Cannot make that clear enough. The hypotenuse always has to be C. So from here, we're just going to plug in basically this entire section, this entire part about Pythagorean Theorem is just plugging in values and solving for the answer. So here's our right angle. So I'm going to draw across from my right angle. Maybe try this one more time. Across from my right angle is side C, because that's my hypotenuse. And so I know I'm looking for C. So A and B doesn't matter. I'm just going to call this one A. I'm going to call this one B. And so we'll do 3 squared plus 4 squared equals C squared. So I've plugged it in. I've used the substitution property. From here, 3 squared is 9. 4 squared is 16. And I'm still looking for C squared. Now I'm just going to simplify. So 9 plus 16 is 25. Now, I want to find the hypotenuse, which means I want C. I want to know what C equals, not C squared. So C squared equals 25, and the inverse operation of squaring is the square root, like we talked about in chapter 3 in section 3.1. So in that section we talked about how our square roots have two answers, a positive and a negative. Well, a negative side length does not make sense. So positive is the only one that makes sense for this. So the square root of 25 is 5. So 5 equals C. And that's how we find the length of the hypotenuse. So here we are. We're going to find the length of the hypotenuse. So again, across from my right angle is my C. Again, I do this just so that I always know. Keep in mind on your test, the sections are all jumbled up. So you'll have section 2 mixed in with section 3, whereas on your homework, they're all split out. So you just want to be careful of that. Again, I'm going to call this side A and this side B. So I'm going to do 12 squared plus 5 squared equals C squared. Because again, it's A squared plus b squared equals c squared. So 12 squared is 144. 5 squared is 25. Again, that equals c squared. And so then 144 plus 25 is 169. And then to undo the square, we're going to square root both sides. And the square root of 169 is 13. And so our hypotenuse, the length of our hypotenuse for this triangle is 13. On to our next triangle. Again, here's my right angle. Across from it is my side C. That's what I'm looking for. We'll call this side A and this one side B. Well, it really doesn't matter. We could call this one A and that one B. And we'll get the same thing. So we have A squared plus B squared equals C squared. That's our Pythagorean Theorem. I'm sorry, I can't talk today, evidently. So we have 7 squared plus 24 squared equals C squared. So we use the substitution property. And now I'm going to simplify. 7 squared is 49. Plus, and then 24 squared is 576. And keep in mind, the reason we're doing the square first is order of operations say that squaring happens before addition. So don't forget, you've got to square before you add. And then 49 plus 576 equals 625. And then to get C by itself, we square root both sides. And so then 25 will equal C, because the square root of 625 is 25. And again, that's how we find C. So let's do some real-world application here. Here we have a baseball diamond, and so square with 90-foot side lengths. To the nearest tenth, we want to find the distance from home plate to second base. Excuse me. So really I just need to think of one of these triangles, and this is going, so right triangle. So that means that this is our side C, even if I went from third base, still side C. So what that means is this is A and this one's B, or B and A, I don't care how we word it. A squared plus B squared equals C squared. We're looking for C, we don't have that length. So then we do 90 squared plus 90 squared equals C squared. And so then 90 squared is 8,100. So plus 8,100. Add these together and we get 16,200 equals C squared. And then the opposite of squaring something is to square root. So when I take the square root of 16,200, I end up with 127.3 feet. And so that is the approximate distance from second base to home plate. Now, I know you're looking at this going, well, why isn't this 90 or 8,100? Because we're taking the square root. If I would have divided by 2, I would have gotten, 8,100. But I'm taking the square root of their sum. So that makes a big difference. Alright, so now we're looking at a Great Pyramid. And it's the Great Pyramid is a square pyramid in Egypt. So to the nearest hundredth, what is the slant height of the Great Pyramid? So this, we're looking for this cursive L here, this little slant height here. Here's our right angle. And we're going to draw an arrow, so that means that this is our C. So we're looking for the hypotenuse. Now you'll see that there are 3 other numbers here. We have that the side length of the square is 230.35. And that the side length of our right triangle is 115.175. And then our height, our height is 146. So I was saying 146.71 before I went into my coughing fit off camera. So from here, you've got to decide, well, which ones do we keep? Well, the thing is we want the sides of the right triangle. So this 0.175, it came from taking the 230.35 and dividing it in half. Because when we drop the height, it goes from the top of the pyramid straight down to the middle of the base. And so since it's in the middle of the base, that means it's half of our square. So from here, we just plug into, a squared plus b squared equals c squared. And so I'm going to call this A, I'm going to call this one B, and we'll go from there. So 115 point, oh, I said I was calling that one B. 146.71 plus 115.175 equals c squared. And when I square each of these numbers, that's important. So 146.71 squared is 221,523.8241 plus, and then 115.175 squared is 13,265.2806.3, and all of that equals c squared. And yes, I would keep as many decimals as you can, because the more you round, the less accurate your answer is. And so I kept all of my decimals for this so that I can have the most accurate answer in the end. When we add these together, I'm going to get 34,789.10473. So right now that's what c squared equals. So to find out what c equals, we're going to take the square root of both sides. And so the square root of this lovely number is 186 point, and it says to the nearest hundredth, so 0.52 equals c. And so that's that many meters. And so that is how we find the hypotenuse using Pythagorean theorem. Until the next video.